Dr. Panraksa, if you start sharing your screen while I'm introducing you. So Dr. Chatchawan Panraksa is an associate professor in the International College of Mahidol University. I know Dr. Panraksa from 2022 when I was looking for someone doing things with Gröbner bases in Thailand. Dr. Bunklab from Chulalongkorn introduced him to me, and then I joined one of his talk online. And then we kept contact. He came to here and I went there, and now we have him here. And Dr. Panraksa, please go ahead.
Okay, thank you very much for the introduction and good afternoon, everyone. Thank you, Dr. Sadeki Manesh and the organizers for the invitation. Today, I want to share something that changed how I think about problem solving in mathematics. It's about Gröbner basics. Gröbner basis, right? So we are going to explore Gröbner basis, and I promise, I hope by the end of this talk, you will see why I call them the Swiss Army knife of mathematics. So I want to make it very accessible to undergraduate students. And this is more like the advertisement of Gröbner basis / SageMath. Okay. So we will start with understanding what Gröbner bases actually are and why you should care. Then we will dive into the core applications. We will get our hand dirty with real examples using SageMath. But I think you can use for any math software like Mathematica or even Python itself. Okay, SageMath is basically built on top of Python. So if you use Python already, SageMath is very convenient to use. Okay, but if you don't know Python, then it is a good starting point anyway, because there are so many functions in mathematics that you can use in SageMath. Okay, and it's free. Okay, that you can use without any subscription. Now, what are Gröbner bases, right? I can give like technical details, but here I will keep it to the minimum. So what exactly are Gröbner bases? So here are the key insight. A Gröbner basis is like Gaussian elimination for polynomial systems. Okay? Just as Gaussian elimination systematically solves linear equations by reducing them to a simple form, right? We are used to the Gaussian elimination for linear equations, right? But then Gröbner bases can solve a bigger set, which are the sets of polynomial equations by transforming them into an equivalent but simpler system. The magic is that this systematic approach works for any polynomial system. I'm not talking about the speed or efficiency of Gröbner bases today. Okay, so that could be the research project in itself as well. Okay, focus on how to use it. Okay, so you can use, for example, equation of circles or any curves. You can think about this as a model for robot arms and maybe cryptographic codes, right? You can transform operations to polynomials. So this gives us one powerful tool to solve many different problems, okay? So think about it, you already know how powerful Gaussian elimination is for linear systems, right? So Gröbner bases extend that same systematic power to the much richer world of polynomial equations. And for undergraduate students, right, this matters because polynomials are everywhere in mathematics and engineering. And basically, many problems in mathematics can be transformed to solving the system of polynomials, right? So why do we call Gröbner bases a Swiss Army knife, right? Just like a Swiss Army knife packs multiple tools into one compact device, Gröbner basis give us multiple problem-solving capabilities in one mathematical framework. We have multiple tools in one system, versatile applications across different fields. A systematic approach that works consistently, and they are essential for modern problem solving. So when you encounter a problem related to polynomials, right, or set of polynomials constraints, whether it is in robotics, graphics, or even puzzle solving, Gröbner basis are offering you the go-to tool. Okay. All right, so this is going to be fun to use as well. Okay, it doesn't have to be like serious mathematics, right? When you solve like puzzle, you can think about Gröbner basis as well. Okay, so let me show you where this Swiss Army knife really shines. Okay, in robotics, they solve motion equations for robot arms and movement planning. And in cryptography, right, you can think about the operation as polynomial systems as well. So you can analyze or even break the polynomial based ciphers. Okay, so for graphics and geometry, they can handle curve intersections and 3D models. Okay, or you can even model high dimension if you want. And yes, they can even solve Sudoku and other constraint satisfaction problems. Okay. So all in all, Gröbner basis can help us to convert complex constraints into solvable algebraic systems, right? That the so-called Gröbner basis. So it's gonna rewrite the set of polynomials into the form that is easier to use. Okay. So this is where the power of systematic solution really shows. Gröbner basis let us convert geometric problems to algebra, right? And eliminate variables systematically, okay, just like Gaussian elimination, right? Find all solutions automatically and handle complex constraint system that would be nearly impossible to solve by hand. Okay, so the keyword here is by hand, because sometimes if you deal with like 5 polynomials, right, for your system and you want to solve, sometimes it's hard to know where to start, right? But Gröbner basis will do it systematically. Okay. So I'll give you a simple example using a SageMath code. Okay, so this is very simple, and you can, use similar code here to solve a more complicated set of polynomials. Okay, so for example, you use SageMath, right? So one hidden agenda for my talk today. So you can start by defining or fixing polynomial ring, right? So the QQ here is for the ring over the field of rational numbers, right? Now, one option or one aspect that you have to specify for Gröbner basis is that you have to specify the order for your variable. Okay, actually, there are many ways that you can order monomials for polynomials, right? If we set order equal to lex here, for example, it just means that you order x, y, t. So this is gonna give parity that you want to get rid of the t first, and then y, and then x, something like that. And you can reorder the variable if you want to get rid of x first or y first. Okay, so let's take a look at a very simple system here. Okay, so let's say we define x as cosine of t and y as sine of t, right? And we have a very important identity, right? Pythagorean identity here, cosine square plus sine square equal to 1, right? You can convert this to polynomial problem, right? Because here we set x equal to cosine of t, right? So you write x minus cosine of t. You don't have to set it equal to 0, right? And y minus sine t, and also for the Pythagorean identity here, then you just write just the polynomial part, okay? On the right-hand side, you imagine that is equal to 0, okay? And then you can just use a command in Chatchawan here, Gröbner basis, right? To compute the Gröbner basis based on the ideal that you define here, okay? So when you look at the Gröbner basis, okay, from this lexicographic order, right? You're gonna see one of the polynomials. Actually, it's gonna show you many polynomials, right? So the first one or the last one depends on the math software that you use. Okay, will show you one polynomial that get rid of the t, okay, or the desired variables that you want to get rid of, okay, if succeed, okay. So for example, it's going to show you x squared plus y squared minus 1 equal to 0. Okay, so this can be used to solve the trig identity as well. Okay, so you can play with this even more exotic trig identities. Okay, so of course this is quite a trivial example here. Okay, now if we move on to robotic application, right? If we simplify the model to just two-dimensional case, right? So we can think about the robot arm as two joint robotic arm, right? So one question is, how can we design a robot arm so that it can reach toward any working space that we want, right? So we can model as follow, but here I'm going to think about the robot arm as a two-dimensional workable space, right? The space that we use robot here, and this is quite applicable because most of the time the working space for the robot would be 2 dimensions, but we can extend this to 3 dimensions as well. Okay, so we write the position x and y. Of course, we define the variables, okay, just similar to the one that we warm up with the trig identity, right? So let's call C1, C2 from the projection to the x-axis for the robot arm number 1, right? The first joint part, okay. C1 and C2 is from the second arm, right? And for S1, S2 are for the projection to the y-axis, right? For the robot arms number 1 and number 2. Okay, so for this, again, we use trig identity, right? And we can write this as a cosine square plus sine square minus 1 equal to 0. But here we have to do it for robot arm number 1 and number 2, right? And again, we can run the Gröbner basis, right, in Chatchawan. Okay. So this is gonna show us the working space. Of course, this is like oversimplified version of the robot arm, right? In reality, you may have to put more constraints, right? For example, there might be some obstructions that you need robot arms to avoid, something like that, some pole that it cannot hit, right? So have to find a way to work around. Okay, so when we solve, right, it's gonna show that the working space would be with the radius 2, right, which is not quite surprising, but this is a oversimplified version. But you can see that if you look at the robot arm, right, robot arm number 1, robot arm number 2, right, so the position of the target would be from the cooperation between the arm number 1, number 2, right, to reach the point that you want the robot to reach. Okay, you can use basically this same template here to solve your polynomial systems. Okay, I actually first encountered Gröbner basis when I was a grad student. Okay, I moved from a research group in dynamical system, okay, which was very analytic, right, to number theory, algebraic number theory, and also elliptic curves. So I didn't know much about algebraic geometry. Okay, even nowadays I know very little about algebraic geometry. However, I try to solve a system of polynomial equations, okay, that is related to my research project. It took me like a couple months, and I could not solve the system of polynomials by hand. Okay, and then I bumped into a textbook of algebraic geometry, and it mentioned about Gröbner basis, and I use it as a black box, just basically like this. Okay, using SageMath, right, and it could solve within like minutes, if not like 10 seconds. Again, that was like 20 years ago. So I don't want you to face into the same fate like me. If somehow you deal with the system of polynomials that you want to solve, right? So the keyword today, the key message today is, if you try to solve a system of polynomials and somehow you struggle, right? Think about using a Gröbner basis. Okay, it could be in Sage, Pali, or Maple Mathematica. Okay, I think any algebra computer system would be able to handle the Gröbner basis. Okay, so nowadays it is the standard function that you can use. Okay, or you can try right now if you have a problem about system of polynomials already, right? So you can say you can try Sage without installing the program on your computer, right? You can use this via sale.sagemath.org, or you can download as well, and you can have another tool, right, that can be used to solve maybe robotic. Actually, recently they try to apply this in AI as well. I just bump into the idea of using AI to make Gröbner basis run faster, something like that. So I have to go back and read it now. Cybersecurity, when you change or transform the algebraic operation to polynomials, and you can use Gröbner basis to solve. Okay, so you can try to use SageMath to use Gröbner basis, and actually you can use SageMath to basically any subjects in undergrads curriculum. Okay, I think it's going to be a great tool for you to use. Think about this as a very powerful calculator that you can use, and it's free as well. Okay, and it can produce a very good graphs. Okay, very good visualization here. Okay, so you can try using SageMath. I mean, sale.sagemath.org, or if you are a little more serious and you want to use on your computer, right, you can download from the sagemath.org. Okay, so I hope you will enjoy using the Gröbner basis in your mathematical problems, okay, or in your computer science project as well. Okay, and hopefully you try SageMath if you haven't tried already. Okay, so I think I'll stop here, and if you have any questions, please ask.
Okay, thanks, Dr. Panraksa, for the nice talk. If anyone has a question from the audience, please raise your hand and we'll call your name to ask your questions. Syed Ghorbani, please go ahead.
Thank you. I really appreciate your clear and engaging presentation. And I have a question. In your opinion, which algorithm currently provides the fastest and most accurate computation of Gröbner basis?
Oh, which one, right? I'm not expert in the Gröbner basis. I have to make a disclaimer here. And I asked an expert in Gröbner basis like a couple months ago when I visit Dr. Sadiki Manesh. Dr. Matthew mentioned that sometimes it's hard to predict which system will be easy to solve or very hard to solve using Gröbner basis. So I think on average, we just have to try and see if it's come up, because for my experience, sometimes when I think that the system is complicated, right? When I use Gröbner basis, maybe within 1 minute, it can give us answer. But for some system, maybe just 3 equations with degree up to 5, then it cannot solve. It took like days and nothing comes out, something like that. So it's kind of weird. And I think it's still wide open for making Gröbner basis more efficient. But in terms of application, I have quite a positive outcome from Gröbner basis. I ran into the hard case. I barely ran into the hard case. Yeah.
Well, about
Maybe I don't deal with the complicated enough systems in my work.
About Gröbner basis algorithms,
Yeah.
Dr. Hashimi also is an expert here, which had a talk
Okay.
yesterday. So maybe we can talk about that later. But
Yeah,
Jonah,
I think
do you
that
have
would
a
be better.
question?
Yes, I have a question. Thanks for really. I'm not from mathematics background, but I think I really enjoyed your talk. So I just wanted to ask: does Gröbner basis solve dynamic problem? Like, can we find optimal solution to a dynamic problem using Gröbner basis?
Yeah, for that, if you can transform your problem to a polynomial, right, and maybe you take derivative first to fit into the constraint of optimization, right, finding maximum, minimum, then you can run the Gröbner basis to solve for the solutions there. Yeah.
Okay, and we can do that too using SageMath as well.
Ah, that's great.
Okay, thank you.
Yeah.
Syed Ghorbani?
Okay, and how do you solve Sudoku using Gröbner basis?
I see. So basically, we can think about the number in each cell, right, as a variable x1, x2, x3 until, let's say, x9. Okay, and then you add the constraint for each row, each column, and probably the diagonal as well, right? So that's going to be the constraint for the Gröbner basis, and then you can solve for each one. Yeah.
Thank you.
Yeah.
Any more questions from the audience? Okay, if not, then let's thank the Dr. Panraksa with a clapping react.